So this is quiz 2 for this unit. To start off quiz 2, we're asking you to find the stress on a 1-inch diameter round piece of steel under a 20,000 pound tensile load. So we know that stress is a load divided by or distributed over a cross-sectional area. So our load here is just the 20,000 pounds, nothing to calculate there. The area is going to be the area of that 1-inch diameter circle. Well, that 1-inch diameter has a 1/2 inch radius. So our area here will be pi times 1/2 inch squared. Calculate that out, that becomes 0.785 square inches. So our stress is at 20,000 pounds divided over that area of 0.785 square inches. Here's 25,477.7. And that is PSI, pounds per square inch. Problem number 2, we have a 1/2 inch diameter, 15-foot long aluminum cable, and it supports 5,500 pounds. The elastic modulus of our aluminum is 10,000 KSI. Now remember, K is kips, so it's 1,000 pounds, or 10 million PSI. Find the elongation in that cable. Well, the formula for elastic modulus is stress divided by strain, which reduces, if we combine all the factors, it's the load times the length divided by the area times delta, which is our change in length, or elongation. So if we rearrange that formula, we find that delta is equal to the load times the length times over our area times the elastic modulus. So our load here was the 5,500 pounds. The length is 15 feet. Now everything else in this is going to be in inches, so we have to do that 15 feet times 12, put it in inches. Our area, we'll need to find the area of a 1/2 inch diameter cable. That's going to be pi times 1/4 squared. 1/2 inch diameter is a 1/4 inch radius. And our elastic modulus has to go in as 10 million pounds per square inch. So on top there, we're going to do 5,500 times 15 times 12 is going to be 990,000 on top. And that's pounds times inches, or inches times pounds, however you want to look at it. On bottom, we find that area, 3.14 times 1/4 inch squared. Then we multiply that times 10 million, giving us 1,962,500. Now this was square inches, so that cancels out here. So all we have for units here is pounds. So the pounds will cancel out as our units. We have inches left up there. 990,000 divided by the 1,962,500 gives us 0.5045. Inches to the 10,000th of an inch. For problem number 3, we're asking you to find the allowable range for dimension that is given is 1.365 inches plus or minus 0.08 inches. So the range is just to take this desired value, 1.365 inches, minus that allowance of 0.08 of an inch. That would give us 1.357 inches. Up to the maximum would be that desired value of 1.365 inches plus that allowance of 0.08 of an inch. Gives us 1.373 inches. So the allowable range here, 1.357 inches to 1.373 inches. Problem number 4, find the measurement of that micrometer. So this is an inch micrometer. It doesn't say so on the dial. Often it will say 0.001 inch, but we know it's an inch because it goes to 1,000th. A metric micrometer would go to 100th of a millimeter, and because it has 2 levels of measurement here on the main scale. So this is saying 2.5 inches, and then another 15 thousandths. So 2.515 inches is the reading of that caliper. And for question number 5, find the reading on this micrometer. So first of all, this is a standard micrometer because it's labeled in 1s here. A metric would be labeled in 5s, and because there's only 4 divisions between numbers. This is 0 inches, unless it's labeled as a 1 to 2 or 2 to 3 micrometer. It starts out as 0 inches. This is 0.6. We have passed that first quarter mark, so that's 0.625. Then on the thimble up here, this is 1 that lines up with our axis. So that's just an additional 1,000th of an inch. So that adds up to 0.626 inches. So once again on the quiz, if you have 4 or more, in other words, 4 or 5 correct, you are good. If you had less than 4, you need to go back and review a little bit and repeat this quiz.